Welcome back to our channel Kenson. This is the fifth part of matter in our surrounding. Before that, if you are not subscribed my channel, please subscribe it and press the bell button for the notification. Our today topic is change of state. We have studied that matter physically divided into three, that is solid, liquid and gas. And matter can exist in these three states depending upon temperature and pressure. Under atmospheric condition, the water existing as a liquid. Okay, under atmospheric conditions, water existing as a liquid. If we are lower the temperature, that is means below 0 degrees Celsius, this water is converted into ice, that is means a solid form. And if you are heat the water, that is means above 100 degrees Celsius, this water is converted into water vapor, that is gaseous form. So, the matter can change into one physical state to another physical state. It is named as a change of state. How we can change the state of matter? By applying temperature and by applying pressure, we can able to change the state of matter. Okay, let us discuss about the effect of change of temperature. Okay, I am going to do a small activity. In this activity, a beaker containing 150 gram of ice. Okay, this beaker containing 150 gram of ice. And I kept a small thermometer to it. In the third step, now I am going to heat in these ice cubes. In what temperature does it melt? Do you know the answer? At what temperature does it melt? Okay, the ice melts at 0 degrees Celsius. Okay, this ice melts at 0 degrees Celsius. Now let us learn about the process. Here, do you know this ice are solid substance? Okay, this ice are solid substance. And in solid substance, these particles are very closely packed. Okay, in solid substance, these particles are very closely packed. And they have a strong cohesive force. When we are supply the heat, okay, when we are heating the ice cubes, it is a temperature. Okay, that is means the temperature increases. So as we know, temperature increases, so its kinetic energy increases. Okay, so these ice cubes, its particles get a kinetic energy. So temperature increases, its kinetic energy increases. So these particles of the ice cube, they start to vibrate in their own position. Okay, they start to vibrate with the greater speed. At a certain temperature, these particles get enough kinetic energy and they break the force of attraction between this particle. Okay, they break the force of attraction between this particle. At the time, they leave their fixed position and they start to move freely in all possible directions. So at this stage we can say the solid substance are changed into liquid. Okay, and this process is named as an melting. Okay, this process is named as an melting. Then at which temperature the solid substance are converted into liquid, it is named as a melting point. Okay, at which temperature the solid substance are converted into liquid, it is named as a melting point. So we can say the 0 degrees Celsius is the melting point of ice. And this process is also known as a fusion. And we can observe one more thing from this activity. That is, its temperature remain constant during the melting of ice. Okay, its temperature remain constant during the melting of ice. And only after all the ice was melted, this temperature is starting to rise. This is because when the solid substance are changed into liquid, the heat energy is applied. It uses to overcome the force of attraction between the particle. Okay, and this heat energy is absorbed by this ice without showing any rise in the temperature. Okay, and we can say this heat energy is hidden into the content of the beaker. So we can say it is latent heat of fusion. Okay, we can define this. The heat energy is required to change 1 kilogram of solid is changes to liquid. Okay, the heat energy is required to change 1 kilogram of solid is changed to liquid at its melting point is named as a latent heat of fusion. Okay, the next term is boiling. Do you know boiling means the liquid substances are changing into gas. Okay, it is named as a boiling. So let us see the process behind it. Okay, here in this activity, and to get beaker, it contains water. Okay, approximately 50 ml of water. And I kept one thermometer. And the last step, now I am going to boil this water. Okay, and here, do you know the liquid substance? Okay, in a liquid, these particles are loosely packed. Okay, in liquid, these particles are almost loosely packed. And when we are heating this water, okay, when we are applying the heat to this water, this get temperature. Okay, that is means its temperature increases. Okay, as a result, the kinetic energy of the particle increases. Okay, when we are heating, these particles get a temperature, so the temperature increases. As a result, the kinetic energy of this particle increases. So, the particle of the water, okay, they start moving with a greater speed. Okay, as a result, this particle of this water, they start moving with a greater speed. At a particular temperature, these particles get enough kinetic energy to break the force of attraction between these particles. Okay, to break the force of attraction between these two particles. And after these particles, they leave their fixed position and they can freely move in all possible directions. At the time, these liquid substances are converted into gas, and this process is named as a boiling. And in which temperature these liquid substances are converted into gas, that is named as a boiling point. Okay, that is named as a boiling point. At which temperature these liquid substances are converted into gas, that is named as a boiling point. So we can say this boiling point of the water is 100 degrees Celsius. Again, the boiling point of the water is 100 degrees Celsius. And like melting, we can able to observe one more observation from this activity. That is, its temperature remain constant during the boiling process. Because when these liquid substances are converted into gas, we are applying the heat energy is used to overcome the force of attraction between the particles. So that energy is added to the content of the beaker, so we can name it as a latent heat of vaporization. Okay, it is defined as the heat energy is required to change 1 liter of water to the gas at its boiling point is named as a latent heat of vaporization. Our second factor, pressure. Okay, let us see how this pressure affects the change of state. Okay, first in the case of a solid, do you know these particles are closely packed and there is no any effect of pressure on solid because these particles are closely packed and they are incompressible. Okay, we can't be able to compress it. And in the case of a liquid, okay, there is no any effect of pressure on liquid because these particles are loosely packed and they are slightly compressible. Okay, we can't able to compress it more. But in the case of a gas, okay, increasing pressure, its volume is decreases. Okay, when we are applying pressure, its pressure increases, so its volume decreases. That is mean these particles are far away from each other. Okay, it is highly compressible compared to solid and liquid. These gases are highly compressible. So when you are applying the pressure, its volume decreases. And when we are apply high pressure to it, these gases is converted into liquid. Okay, when you are apply high pressure on it, these gases are converted into liquid. So we can say it is a liquefaction of gas. And let us see the process behind it. Here, these gaseous particles are present in the cylinder, and now we are going to give a pressure with a piston. Okay, when we are apply the pressure, these particles are come closer, and again we are apply the pressure with this piston. These particles are again come too close together. So that is means the interparticle distance between this particle is decreases. Okay, so that's why this moment is decreases. So its kinetic energy decreases. The kinetic energy decreases means its temperature decreases. So we can say applying high pressure, that is means increasing pressure and decreasing temperature, we can able to liquefy the gas. And this process is named as a liquefaction of gas. The next part we will see with another interesting topic, that is evaporation. So until then, bye.